Chapter 5 enhances our supply and demand model by adding the concept of elasticity. We're going to start by looking at the price elasticity of demand, but there are also the price elasticity of supply, the income elasticity of demand, and the cross-price elasticity of demand. So when we talk about elasticity, any type of elasticity is measuring how quantity responds to changes in other variables, other things equal. So if we have some change and we have an expected directional change in quantity, the question here is how big is that change? So when we talked about the law of demand, we said if the price goes up, quantity demanded is expected to decrease. But does it decrease a lot or does it decrease just a little? So when we say that something is elastic, we're just saying that it's very responsive. When we say that something is inelastic, we're saying it's not very responsive. So the intuition behind the price elasticity of demand. I've got a demand curve drawn here, and the question is, when the price changes, as we move along that demand curve, does the quantity demanded just change a little bit? And if so, we say that we have inelastic demand. So we can see with this demand curve here, when we move from here to here along this demand curve, here's the change in price that happens, and we have a relatively small change in quantity demanded, and so we would interpret this as being a fairly inelastic demand curve. On the other hand, we might have other goods where we see elastic demand. So if we look at this demand curve here, we start off with the same price and quantity as we did on the steeper demand curve, but the same increase in price moving along this demand curve would result in a very large change in quantity demanded. And so we're very responsive to the price change. And so we would say that we have elastic demand. So goods with inelastic demand are goods where we don't change our behavior a lot. Things like gasoline or tobacco products or alcoholic beverages perhaps. Those all show fairly inelastic demand. Goods with elastic demand would be things where we maybe don't see them as being as necessary. And so the price goes up, we stop buying them. So the technical definition, the price elasticity of demand, or my notation here, E with a D stands for price elasticity of demand, measures the percent change in quantity demanded that results from a 1% change in price. And we're going to deviate from the standard percent change calculation a little bit in this calculation. But before we get into that, we're basically just saying how big is the change in quantity demanded in percentage terms relative to this change in price. So usually when we calculate a percent change, we would say look at how much something changes divided by the starting point. So as an example, suppose that we had a quantity that goes from 10 to 20. We would say that the percent change is equal to, we went up by 10, and we divide by our starting point. We started with a quantity of 10, and so we get a fraction of 1, or we would say that there is a 100% increase. Now consider a second scenario where we just move in the opposite direction. We go from a quantity of 20 down to a quantity of 10. When we measure the percent change now, we have a change of minus 10. We divide by our starting quantity of 20 and we get minus 1/2 or minus 50%. So the exact same change but in opposite directions gives us slightly different measure, actually very different measurements in this case, and that can make it difficult to interpret. And so instead we're going to look at the changes divided by the average value. So with both of these calculations, we would measure this quasi-percent change. We have a change of 10, whether it's positive or negative, and we divide by the average quantity, which in this case would be 15, the average of 10 and 20, and we're going to get consistent measurements regardless of the direction of the change. So, for those of you that like the formula to be spelled out a lot more, another way that we could write this, if we have a quantity before some change and a quantity after the change, the new quantity minus the old quantity, that would be how much it's changed. And then we divide by the average. And a lot of times you can just eyeball the average. Like if we go from 10 to 20, the average is 15. Or you could add those two values together and divide by 2, you get the same answer. And then we're going to divide by the percent change in price. So how much has the price changed divided by the average price. So we need to be a little bit careful that elasticity is not really the same thing as slope. Slope measures the absolute change in the y variable divided by the absolute change in the x variable. Here we're looking at percent changes rather than the simple changes. So that creates a little bit of confusion sometimes in terms of interpretation. If we have a demand curve here, so here's the quantity demanded in price, and we've got a demand curve like this, the closer we get to the x-axis, so we have a higher quantity and a lower price, we're going to get more inelastic measurements. Simply because of the fact that when quantity is very large, these changes are going to look small in relative terms. And similarly, if we move this direction, we're going to get more elastic measurements. So we don't need to worry too much about that, but we should just be aware that the elasticity changes as we move along a straight line demand curve. Now, suppose that we have two demand curves that we're able to graph together, and they go through the same point. So if we have two demand curves like this that intersect, I'll call this demand 1 and demand 2, we could conclude that the flatter curve, in this case demand 2, is always more elastic than the steeper curve. The steeper curve here, which would be demand 1, is always more inelastic for any quantity. And so we do a lot of times use, just eyeballing the slope to think about elasticity. Steeper curves tend to be more inelastic, flatter demand curves tend to be more elastic. So we can measure this elasticity, and at this point the measurement just sounds like we're crunching through the numbers, which is essentially what we're doing, but how do we interpret the result that we get? So if we get a measurement that's exactly equal to 0, so looking at the equation up here, percent change in quantity demanded divided by percent change in price. Well, any fraction is equal to 0 if the numerator here is equal to 0. So an elasticity measurement of 0 would imply that we simply don't see any change in quantity demanded regardless of what happens to price. That would be like the medical necessities that I talked about in a previous lecture. Regardless of what happens to the price, we try to keep our quantity purchase exactly the same because of some basic necessity. So in that case, we would say that we have perfectly inelastic demand. Quantity never really responds to the price changes. We're going to look at all of these measurements in absolute values simply because if the quantity is increasing, the price must be decreasing. Or if the quantity is decreasing, the price must be increasing. These two changes are always going to have opposite signs, and so technically we always get a negative measurement. It's easier to think about them as positive numbers. And so if we get a measurement in absolute value that's between 0 and 1, what is that telling us? Well, any fraction is between 0 and 1 if the numerator here, our percent change in quantity demanded, is smaller than the denominator, the percent change in price. So our change in quantity demanded is small relative to the change in price, so that's what we call inelastic demand. We get a relatively small response in quantity. If we happen to get a measurement that's exactly equal to 1 in absolute value, that would simply imply that these two values are the same. And there's nothing really special about that, but it's sort of the dividing line between what we call inelastic and what we call elastic. So if we happen to get a measurement exactly equal to 1, we call that unitary elastic demand, or sometimes unit elastic demand. If we get an elasticity measurement that's greater than 1 in absolute value, any fraction is greater than 1 if the numerator is larger than the denominator. And so that's telling us that the percent change in quantity demanded is much larger than the percent change in price, or at least somewhat larger than the percent change in price. And so we would interpret that as being elastic demand. So there's a number of determinants of the elasticity of demand. Determinants meaning, what affects this measurement. So one of the common determinants is the availability of substitutes. If a good has very few substitutes, we're going to get a much more inelastic measurement. If a good has lots of substitutes, we're going to get a much more elastic measurement. And the idea here is if there's lots of substitutes out there, if the price of this good changes, there's a lot of other things we can switch to. If there aren't very many substitutes, then we're stuck with a tougher choice. There's fewer substitute goods that we could switch to buying in response to the price change. And so we're left with, do we keep buying it even though the price has changed, or do we just not buy it at all? How we define the market also has an impact. So if we use a very broad definition, we're going to get more inelastic measurements. If we use a very narrow definition, we're going to get more elastic measurements. So what do we mean by market definition? Well, a broad definition might be something like, I talk about the market for over-the-counter painkillers. So we've got a lot of over-the-counter painkillers, but I've just lumped them into the same category. And so there's very few substitutes that remain. Not that there aren't any other substitutes, but there's fewer substitutes. If I define the market very narrowly and say, the market for buffered aspirin, well, now there's lots of other over-the-counter painkillers we could be switching to, and so we're going to see a much bigger response to price changes because of the greater availability of substitutes. And that's simply driven by how we define the market. And how we define the market is often arbitrary. So we need to be careful, are we defining the market correctly for the questions we're trying to ask? But that's really for a more advanced class. The degree of necessity. So obviously things that we think are more necessary are going to have more inelastic demand. Things that we think are more frivolous or less necessary, we're going to see more elastic demand. We're more responsive to price changes. Finally, the time horizon. If we have a very narrow time horizon, we tend to get more inelastic measurements simply because we have trouble changing our habits. Over longer periods of time, we tend to get more elastic responses. So if we think about the market for gasoline, if gasoline prices jump suddenly, which they appear to be doing right now, we may not be able to respond quickly to that. We still need to get to work. We still want to get our kids to sporting events or whatever it is that we're driving our cars for, and we may not change our behaviors immediately. But if the gas prices go up and remain high over a longer period of time, that's when we start to see more reaction. We start to see people trading in larger vehicles for smaller, more fuel-efficient vehicles. We see more people carpooling or taking public transportation. And so we have more time to adjust, and that tends to give us more elastic measurements. The final determinant of the price elasticity demand, and this is one that seems the most counterintuitive to me, relates to the percent of income devoted to purchasing the good. So the argument here is that if something takes up a small fraction of your overall income, we expect to get a more inelastic measurement. So think about something that you don't buy very often and doesn't cost very much. I buy cough drops probably twice a year. And so I go to the store when I'm feeling bad and I've got a cough and I buy a packet of cough drops. And to be honest, I have no idea what I spent on the cough drops last time I bought them. So the next time I get sick, I go back to the store and perhaps the price has gone up, from $3 to $4 for a bag of cough drops. If I don't even remember what the price was before, I'm not going to really respond to that change. It's not a big part of my budget. I don't really care about the price so much. And if I don't realize that the price has changed, I'm not going to change my behavior, and that gives us this inelastic demand. Something that eats up a lot of our income, we're going to be more aware of the changes, and so we're likely to get a bigger response. This one I always struggle with a little bit, though, because when I think about things that take up a big chunk of my income, there are things like my utility bills and my mortgage payment or my car payment, and these are things that I all view as necessity, and because they're necessities, I have an inelastic measurement separate from the fact that they do take up a big chunk of my income. So, one of the useful applications of the price elasticity of demand is its relation with industry-wide total revenue. So, recall, total revenue we can write as price times quantity. And if I do some fancy mathematical manipulation, I could rearrange this and get an equation which is at least approximately equivalent. Percent change in total revenue is equal to the percent change in quantity plus the percent change in price. So usually I've confused some students here because I've gone from multiplying things to adding them together. If you want to see the mathematical proof, it involves taking the natural log of both sides of the equation, and I've probably lost most of you, and that's okay. It's not really that important. But in any case, if we see that the price is increasing, so the price here is going up, quantity demanded would be going down in response, and our question is, what happens to total revenue for the industry? The price change is pushing our total revenue up, but the quantity change is pushing total revenue down. To know what happens to overall total revenue, we need to know which of these effects is stronger, and that's what elasticity tells us. So if we have inelastic demand, so with inelastic demand, an increase in price results in a decreased quantity demanded, But if we have inelastic demand, the percent change in quantity is small relative to the percent change in price. So this is the bigger of the two changes, and as a result, we would see industry-wide total revenue increasing. So, we see industries using this strategically. If we look at OPEC, the oil and petroleum exporting countries, they have a product which has very inelastic demand, and they're very aware of that. And so their strategy is that they can work to raise the price of their product, knowing that we'll continue to buy almost as much, and that will enhance their revenues. But if we have a good with elastic demand, when the price goes up, quantity demanded goes down, but with elastic demand, it's the quantity demanded that is the bigger change, and we would see that total revenue is actually declining. So in this case, it would not be a good strategy to raise the price of your product if that's going to drive all of your customers away. One final comment I should make about this is we are focusing on industry-wide total revenue, not saying what happens to every firm's revenue. So if we were looking again at the OPEC countries, if they're able to raise prices because demand is inelastic, their total revenue collectively is going to be rising, but that doesn't mean that every single member of OPEC is going to see their total revenue increasing. It might not be true for every single provider in the industry. So that gives us a nice introduction to the price elasticity of demand. There's going to be two more short lectures prepared, one talking about the price elasticity of supply, and the other one talking about the income elasticity of demand and the cross-price elasticity of demand. We'll conclude our coverage of Chapter 5 with some practice problems where we actually do some of these measurements.